Imagine spending hours debugging with your AI coding assistant, only to realize you've burned through $50 worth of API tokens again. This isn't just a minor annoyance. It's a recurring problem for developers working with large code bases. The real issue isn't the AI model itself, but the way we feed it information. When you ask tools like Claude Code or Cursor to search for something specific, they often pull in hundreds of irrelevant code snippets. This not only wastes tokens, but also increases latency and leads to more hallucinations, sending you down endless debugging rabbit holes. Let's explore how to fix this. Every wasted token costs you money and time. When irrelevant code chunks are included in your AI's context window, not only does it slow down your workflow, but it also increases the chances of the AI making mistakes. These mistakes, or hallucinations, can lead you further away from solving your actual problem. The more irrelevant data your AI processes, the more tokens you burn, and the more time you spend debugging instead of building. Clearly, there's a need for a smarter way to manage what your AI assistant sees. Enter DeepContext, a game-changing open-source tool designed to bring semantic search to large codebases. DeepContext acts as a Model Context Protocol (MCP) server, enabling AI coding agents to understand your code at a deeper level. Instead of flooding your AI with every keyword match, DeepContext returns only the most relevant code snippets. Think of it as the difference between asking a librarian for any book with the word dragon versus asking for fantasy novels about dragon trainers. DeepContext gives you exactly what you need, saving both time and tokens. DeepContext combines several advanced technologies to deliver precise results. It uses vector embeddings to capture the semantic meaning of your code, BM25 lexical search for exact identifier matches, and Jina re-ranking to ensure the most relevant results are prioritized. Additionally, tree-sitter AST parsing allows DeepContext to understand your code structure at the compiler level. This hybrid approach means DeepContext can reduce token usage by about 40% compared to traditional grep-based searches, while also operating 50% faster. When you use traditional search tools like grep, you get everything class definitions, test mocks, comments, and even outdated Todo notes. Your AI assistant can't distinguish what's relevant, so it processes everything, wasting tokens and your time. This approach is especially problematic in large code bases, where irrelevant matches can number in the hundreds or thousands. The result? Bloated context windows, higher costs, and more confusion. Consider a developer working on a V2X collision avoidance system with over 15,000 files. When searching for authentication timeouts, grep returned 847 matches. The AI assistant processed them all, quickly exhausting the token budget. This scenario highlights the inefficiency of traditional search methods and the urgent need for smarter, context-aware tools like DeepContext. DeepContext doesn't just look for text patterns, it understands relationships between code elements. For example, searching for authentication logic retrieves functions related to login handling, session management, token generation, and more, even if they don't explicitly use the word authentication. This is possible thanks to tree-sitter AST, parsing vector embeddings, and BM25 search, all working together to deliver truly relevant results. Let's break down the three key technologies behind DeepContext. First, tree-sitter AST parsing creates a structured tree of your code, capturing functions, classes, and their relationships. Second, vector embeddings allow DeepContext to recognize code that performs similar operations, regardless of naming conventions. Third, BM25 lexical search ensures that exact identifier matches are still possible when you need them. Finally, Jina re-ranking brings it all together, ordering results by true relevance. Getting started with DeepContext is straightforward if you're comfortable with Python and have an MCP-compatible AI client. You'll need Python 3.9 plus Node.js and Git. After cloning the repository and setting up a virtual environment, you install dependencies and configure your MCP server. Indexing your codebase is a one-time process, and DeepContext automatically updates as files change. For most projects, the initial setup takes just 10-15 minutes. Let's compare DeepContext to traditional grep with real examples. Searching for logging with grep might return thousands of matches, including every file that imports the logging library. DeepContext, on the other hand, returns only the functions that actually log authentication events. This precision saves tokens and makes your AI assistant far more useful for real-world development tasks. DeepContext excels at tracing code dependencies. For example, if you ask where the user repository class is used, DeepContext can follow imports, method calls, and inheritance to show you actual usage, not just type annotations. This is invaluable during refactoring, as it reveals where code actually runs and needs updating, rather than just where it's mentioned. With DeepContext, you can ask for examples of how a service, like email service, is used. Instead of just finding class names, DeepContext returns actual usage contexts, including surrounding code. This helps your AI assistant learn your team's best practices, error handling, and retry logic directly from real implementations, making it a powerful tool for onboarding and code reviews. DeepContext currently focuses on Python and TypeScript. If your stack includes Java, Go, Rust, or Ruby, you'll need to wait for expanded language support or contribute your own parsers. The tool also requires MCP-compatible AI clients, and initial indexing of very large repositories can take time. However, once set up, incremental updates are fast and efficient. Token costs are just the tip of the iceberg. The real expense is developer time lost to irrelevant results and manual searches. DeepContext optimizes for what matters most, getting developers the right information immediately. For a team of 10, saving just 30 minutes per day adds up to over 100 hours each month, time that can be spent shipping features instead of fighting tools. DeepContext is fully open source under the MIT license, meaning you own your installation. There are no usage limits, pricing tiers, or vendor lock-in. Security-conscious teams can audit the codebase, customize search algorithms, and add language support as needed. There's even a hosted version with free trial tokens if you want to test before self-hosting. Open source gives you the flexibility and control to make DeepContext work for your unique needs. The MCP ecosystem is rapidly expanding, with new tools and integrations emerging all the time. DeepContext benefits from this standardization, automatically working with new AI coding agents as they adopt MCP. Community requests are driving support for more languages and multi-repository indexing. The future of AI-assisted development is moving toward intelligent, context-aware assistance, and DeepContext is paving the way. If you're spending more than $20 a month on AI coding assistant API calls, DeepContext can pay for itself in saved tokens within weeks. For teams struggling with large codebases, the productivity gains are immediate. And if you're building AI-powered development tools, DeepContext's hybrid search architecture shows how combining semantic and lexical approaches delivers the best results. The 30-minute setup is a small investment for a huge return. Your token budget and your team will thank you.